Okay, so I'm going to talk a little bit about transition metals and how they form ionic bonds, just to help you out because I know a lot of people have had some trouble with it. So I want to start by helping you define what transition elements are a little bit better and why they're special. So you should know that these right here in this center box here are our transition metals. So everything I'm shading gray or green is a transition metal. The problem is it's a little bit confusing because you see this that says basic metals down here that are right before our metalloids, as they're called, this line right here. Right before we get there, you actually have these post-transition metals, a lot of people call them. And they a lot of times act like transition metals. And the reason all this is important is because in this area, there's another orbital. It's a d orbital. And that d orbital, and that encompasses everything here, it has a way of allowing electrons to slip in and out of metals from their valence shell. That means they're going to form different charges. Now, if you don't understand what any of that means, you need to go back and look at some of the other videos that I've done so that you understand that when we talk about oxidation number, when we talk about charge, it's all about the outer shell of electrons and it's how many they have. And so most of the time you can tell things by what column they are on the periodic table because they either want to fill up that outer shell or empty that outer shell so that the last shell is filled. And that's what determines what kind of charge they're going to take, how many electrons they're going to give away or take in. But all of our transition metals, they can form different ones. And so you have different charges for the exact same metal, such as iron here. So let's take a look at it. So iron naturally forms in two different charges. That's ionic cations is what it forms, okay? One is a positive 2 and one is a positive 3. Notice when it's up top, it's a charge. If you don't know that, you need to look at those past videos. But the fact that it forms at two different charges naturally means it can bond with even the same element. So if we're talking about combining with something, let's combine it with oxygen both times. And you should know from the previous video how to look at the periodic table and be able to figure out how to find the charge of something like oxygen. So if you don't remember, you just count over 1, 2, skip the transition metals, 3, 4, then down 3, 2. So oxygen's -2 because we go positive 1, positive 2, positive 3 can go either way. Carbon's usually -4, -3, -2 for oxygen. So that's how we know oxygen. And we can write that in our formulas. Oxygen's always going to be -2 in this case anyway. All right, so now we have two different things we're going to combine. Two of the same elements. We're always combining iron and oxygen, iron and oxygen. Oxygen's going to stay the same oxidation number, but because iron has two different oxidation numbers, it's going to form two different compounds. So if I start my next step where I write the two elements together, and then I do my cross-oxidation method, and again, all this is the same as it was in the last video, where you take just the number of one element, it crosses to the other element, and becomes the subscript of how many it is. Do the same thing with the charge from iron, and know that that does not have a positive or negative to it. It is just a number at that point. And we're going to do the same thing over here, where we take that to there, that to there. And this actually creates two different things, because if you remember, you can reduce this one, and it would just be iron and oxygen, and it's a 1-to-1 ratio because they have the same magnitude of charge. And so when you reduce it, you get that. And also remember that we don't write ones, we leave it blank. That's very important because it's redundant. I wouldn't have written Fe if I didn't have at least one iron. I guess I do need to make that a better looking E. Okay, over here though, it doesn't reduce. So I'm going to get Fe2 O3. That's going to be it. So these are two different ionic bonds. They're the same elements that have come together, but they came together differently because of that original charge of iron. So we have to define that in the name. And this is where transition metals are a big difference. So the naming, you start with the name the same as you always would the name of that first element. And so in this case, our cation is iron, because the cation has to go first. And it's the same in both of them, iron. Notice I don't capitalize it when I'm writing the formal name. But then I need a space, and in parentheses, I need to indicate which iron I was using. And here I was using iron 2, so in Roman numerals, I'm going to write capital I, in parentheses, so I know that it's iron 2. And then you translate the last one just like normal, where you end it with IDE. If you don't remember that, look into that last video. Oxide. However, over here I have iron 3 oxide. And so see, that name is needed in order to say which iron you were using. And so it has nothing to do with your final formula other than that is how they're combined. But the name part, you need to go all the way back to which charged ion you were using, which charged cation you were using for the transition metal. So for iron, was I using iron 2 or was I using iron 3? And that has to be in the name, okay? Now, I know some people also have trouble with the Roman numerals, so let's take a look at that. So on that test, I've got a lot of people writing a whole lot of different things. You're only going to need about numbers to 6. So let me just show you the Roman numerals to 6. Now, all a 1 is in Roman numerals is a capital I. And so that's all you need to write for it. You can type that in too. In fact, that's how we're going to count the first 3 is 2 is just 2 capital I's. And so you can type it in I. A 3 is 3 capital I's. Now I'm going to skip 1 for a second and tell you what 5 is, because 5 is just a capital V. And so all you got to do is type in a capital V if you need a 5. And so 4 and 6 are all determined by the fact that 1 is an I and 5 is a V. So if an I comes before a V, as it does like that, capital I, capital V, it's going to equal 4. If it comes after the V, it's added to it. And so it is a 6. And so these are all the ones you need. And yes, you can do all of this by just typing in regular letters, capital I, capital II, capital III, capital I, capital V, capital V, capital V, capital I. That's all you got to do. I have people putting L's and things like that. L, if I remember correctly, is 50 in Roman numerals. So don't do that. Just capital I's and capital V's. That's all you need. The only other thing I can think about is I see a lot of people forgetting in the English language, we have spaces between words and numbers and things like that. So notice when I wrote iron, I then had a space before I had 3, and then another space before I had oxide. Notice space, space. That's it.